Hello everybody, this is 4.5 comparing functions, and you're going to do IXL, and this is what it's going to look like. So the question asks, function A and function B are linear functions, and which statement is true? So always read this down here. Okay, these are the options, so it's one or the other. We're talking about the slope, and then we're comparing function A to function B. So here we're comparing the function. Is the slope of function A greater than B, or is the slope of function A less than B? So all we're looking at is slope from two different representations. So function A is a graph. So how do you find slope from a graph? You guys know this, it's rise over run. Okay, there's a point there, there's a point there. I can count up 1, 2, 3, 4, 5 over 1. So the slope is 5 over 1, or 5. So the slope of function A is 5. And the slope of function B, hopefully you know this. Okay. The slope is the one before the x. So the slope of function B is 4. So the question is the slope of function A greater or less than function B? And the answer, of course, is right here. Function A is greater. Let's try another one. This time we're comparing a table to a graph. And we're still looking for slope of the two different functions. So function A, slope from a table. Remember, it's the change in y over the change in x. So from here to here, I am getting bigger by 4. You're going up on your number line by 4. From -9 to -7, that's also getting bigger by 2. So our slope is the rise over run, 4 over 2, which is 2. So the slope of function A is 2. Let's compare that to the slope of function B. Find 2 points on your graph. This looks similar to the last one. I go up 1, 2, 3, 4, 5, and over 1. They're not always going to be the same. Okay, the slope of B is 5. So is the slope of function A greater or less than B? And the answer for this one, too, is obviously less. Okay. All right, what do we have? Still looking at slope. We have a graph and an equation. So slope, always pay attention to what it says here. They're going to change soon. All right, the slope of this graph, let's see, I have a point there, I've got a point there. Remember, any 2 points that's easy to read, you can use them. Rise over run, 1, 2, 3, 4, 5, and I run once. So again, the slope is 5. 5 over 1 is 5. And the slope of function B is this number 1 in front of x, so the slope of function B is 1. This time A is greater. Okay, then we're going to look at another one with slope. Okay, we have a table and a graph again. Always pause the video and try it on your own whenever you can, because we have done one like this. And we have function A. Change in y over change in x. Okay, we're going to get bigger here. Every time we're going to add, let's see, to get from 24 to 8, what's the difference between 24 and 8? The difference between 24 and 8 is 16. We know it's getting bigger. If you want to know how to do that on your calculator, if you can't do it in your head, you take y2 and subtract y1. So 8, make it negative on your calculator, minus 24, make it negative, and then hit the equal sign and you get 16. All right, I'm not going to do that for this one, just going from -7 to -3. You have it on your desk if you need it. This is going up by 4, and it's the y over the x. So 16 over 4, which is 4. So the slope of A is 4. The slope of B, okay, use any 2 points, it doesn't matter. Those two are right there. Up 1 over 1, the slope is 1. A looks to be bigger than B this time, so there you go. Still working on slope. Okay, what's the slope of each one? This one is getting bigger by 4, getting bigger by 2. So the slope is 4 over 2, which is 2. And the slope of B is right there, 4. So it looks like A is smaller than B. Which one says A is less? That's this one. Okay. All right, now we're on to something different. So now we're comparing the y-intercept. So once you get a little bit higher in IXL, you have to pay attention to what they're asking for. That's going to mess you up if you don't. So we're looking at the y-intercept. All right, these are pretty easy. The y-intercept, you guys know from an equation, is the b, which is this 3. And the y-intercept from a graph is where it hits the y-axis. That looks like negative 3. So we have a positive 3 and a negative 3. A is positive 3, so A is greater. Comparing 3 with negative 3. Okay, which statement is true? Again, we're comparing the y-intercept again. So what's the y-intercept from the table? This is the hardest one, okay, when you have a table. You need to find the slope first. The slope is getting smaller. The y is getting smaller. We have a negative, nope, sorry, that's getting bigger. Positive 4, getting bigger, and this is also getting bigger by 2. So once we know the slope, we then can find the y-intercept. So this is 4 over 2, which is 2. This is the m, okay? M is 2. But we need to find the y-intercept. You can do it multiple ways. I'm going to continue to do it the way I've been teaching it this year, where we are going to use point slope form. Y minus y1 equals m times x minus x1. We're going to plug in any x and y that corresponds. So when I can, I like to use positive numbers because it messes people up less. So I'm going to use that x and y, and of course my m, which is 2. Y minus 6 equals 2 times x minus 2. Okay, there's a 2 here and a 2 here, right? All right, distribute. We have y minus 6 equals 2x minus 4. If you need to, you can write somewhere else. If you're running out of room, I can move this. That makes it nice for me. I'm going to add 6 to both sides of that line to get it in slope-intercept. There were multiple ways to get there, but that's what we needed so we could find the y-intercept, which I will highlight in blue right there. So that's the one for A, and the one for B, actually I can leave that here. That's right here, which is the number negative 2. Which one's bigger? A is bigger. Positive 2 is bigger than negative 2. Okay, that is the hardest kind that we have here. All right, this time we want to know the y value. We want to know the y when x is 1 for each function. So from a table, from an equation, that's pretty easy. You're just going to plug in 1 for x and find the y. Okay, so we're plugging in 1 for x. 4 times 1, y equals 4 minus 1, which is 3. So what's greater, that one or the y value when x is 1 on the graph? So find x is 1, which is right here. Follow that up to this and then read that y value, which is a 5. Looks like 3 is less than 5, so function A is less than function B, which is the bottom one. All right, y-intercept again. Now we're doing y-intercept again. Okay, what is the y-intercept of each one? We're going to compare. Remember, this table is the hardest one, so we're going to practice it again. Okay, we're going to first find the slope, and then I'm going to do the work on the side here. Find the slope. This is getting bigger by 8. Here we're getting bigger also by 8. That means the slope, the change in y over the change in x, is 8 over 8, which is just 1. That's our slope. I'm going to write this over here so we know this is function A. Okay, so don't get confused. So we have an m of 1, we just found it. And I'm going to use the x and y here. I'll even write them down over here so you have them. 5, 1 for x and y. And we're gonna use a point slope form. Y minus y1 equals m times x minus x1. Just when you think you're done with that, you have to do it again. Y minus 1 equals, the slope is also 1, times x minus 5. Then we distribute to get 1x minus 5, because 1 times anything is still 1. I just have to slide it down. And we're going to add 1 to both sides. So we have our b here. Y equals 1x minus 4. So we have our b of negative 4. And we have our b of negative 1. Again, function A is right here. So is negative 4 greater or less than negative 1? And it is less. Negative 4 is less than negative 1, which is this guy. A is less than B. All right, function A and B are linear. We're trying to find the y value again when we plug in an x. So let's plug in the x of negative 6 over here. So we have 4/3 times our negative 6. I'll make it a fraction, put it over 1, then subtract 2. You guys can do that on your calculator, or you can simplify. I can divide 3 out of both of those, getting a negative 2 up here. 4 times negative 2 is negative 8, and we subtract 2. So y equals negative 10 over here for function A. And we want the y when x is negative 6 over here. Guess what we need? We need the equation again. So we need the slope first. Up 3, up 2, slope is 3 over 2. Okay, I can use my point slope form and plug in any x and y. Go ahead and use the top one this time because there's no negatives. That one works fine for me. So the y1 is 14. So y minus 14 equals the slope of 3/2 times x minus 6. Distribute. Y minus 14 equals 3/2 x minus, I'm just going to write it, 3/2 times 6 over 1. Okay, these cancel here. I get a 3 up here when I divide both by 2. This is y minus 14 equals 3/2 x minus 9. And we'll add our 14 to both sides. to get our y-alone and our slope-intercept form. So we have, let's use blue, we have a y-intercept, we have a y of -10, and we have, oh, we don't have it yet. We need to plug in -6 for x. -6 for x, let's see. I'll do it down here. We have y equals 3/2 x plus 5. We're going to plug in -6. Okay, so we plugged in -6 for x, and we're just going to solve that. 3/2 times -6 is, let's see, divide these by 2. I'll get a -3. That's a -9 plus 5. And that's a -4. So we're comparing function A, which is -10, to function B, which is -4. Which one's greater? Looks like B is greater, which means A, here it is, A is less. -4 is actually bigger than -10. Lots of things to think about when you do these. And that's it, I guess. Check for Google Classroom for your assignment.